On to question 4, where we need to express x squared plus 5x plus 7 in completed square form. So the rule is take the number of x's and halve it and put it in the bracket with the x and square it. Then take away that number squared and we need to add 7. So there's my final answer, x plus 2.5 squared minus 6.25 plus 7. I converted the 2.5 to a decimal number because it looks neater to have all decimals rather than a mixture of decimals and fractions in the same expression. So there's my final answer. Question 4, Part B, Part 1. Find the coordinates of the vertex of the curve. Well, we've already found the completed square form, and we can read the coordinates of the vertex straight from this form. So the coordinates of the vertex, change the sign of the number that's in the bracket with the x, and that's the x coordinate of the vertex. The y coordinate is the number on the end. For Part B, Part 2, the equation of the line of symmetry of the curve. This is going to be a vertical line, so it's going to be x equals, and it's going to go through the vertex. So x equals minus 2.5 is the answer. Question 4, Part B, Part 3, we need to sketch the curve, and we need to state the value of the intercept on the y-axis. And if you go back to the original expression right at the very beginning of the question, x squared plus 5x plus 7, that tells you immediately that the y-intercept is going to be 7. And also write in the coordinates of the vertex, since we know those two. Question 4, Part C. We need the geometrical transformation that maps the graph of y equals x squared onto the graph of y equals x squared plus 5x plus 7. To find what the transformation is, it's easier to write it in completed square form, and the name of the transformation is a translation. It's a similar word to transformation, but the word transformation won't do here. You need to write translation. And the coordinates of the translation, the vector for the translation, is minus 2.5, 0.75. Closely related to the coordinates of the vertex.